and we're going to go over something new today. Now, last week we covered how to find the mean and standard deviation. We ended up talking about the empirical rule. Those of you that didn't have the empirical rule, there it is. Basically, if you don't know the probability or percentage or the area under the curve, you can do it with the empirical rule, but that's guesstimating, okay? It's kind of rule of thumb. It's kind of like not calculating. So if I asked you how many people are less than one standard deviation, you'll tell me 34 and 34 is 68. Well, one standard deviation would be where? Right here. So if I asked you if that standard deviation, if the mean, let me just go ahead and, if the mean X bar is equal to 125, let's talk about SAT score, and the standard deviation is equal to 5, then this is 125. What is this? 130. What is this? 135. What is this? 140. And this is 120, 115, and 110. If I asked you how many people scored below 130, and you have no idea how to calculate it, you can use the empirical rule and say, well, below 130 would be 34, 34, and 16, 16, 16, and 68 is 84%. And you would say 84% made less than 130. How many made above 135? Well, that'd be 2.5%. Okay? That's how you use the empirical rule. Is it important? Yes, it is very important. You need to understand, not just to pass this class, you need to understand it in any type of statistical situation. That's how you read, that's how a person just off the cuff knows how to do statistics, especially if they're given a mean and standard deviation. The mean and standard deviation are two of the most important numbers that you can calculate. Yes, ma'am? We haven't got through yet. Can I be in charge for a while?
I'm just making sure. I thought I could say.
Yes, ma'am.
So you said what?
No.
Yeah.
No. What was
You
your
said
question?
135. You said 235. You went calculate 10.
I may be. I just now most books, this 0.15 don't exist.
Oh, okay.
This 0.15 is calculated in here to 2.5.
Oh.
In some books, the empirical rule will be like this. In some books, this will be off and this will be 2.5. That 0.15 doesn't really mean anything. Now, if you're given this on a test or homework and they ask you how many scored above 140, then you'd say 0.15%. But most of the time, it's just going to be a generalization. Okay, so that's 2.5. That's 16. I included it. I said 16. 16 plus 68 is 84. So that's how you use the empirical rule. Usually, an empirical rule question is going to give you what? A mean and a what? Standard deviation. That's why it's so important for you to actually know how to find the mean and standard deviation. That's how you use it. Yes, sir.
And does that apply not just to the bell-shaped curve, but even to skewed right?
Pretty much. Most of the questions that ask you about mean and standard deviation is assuming it's a normal distribution.
Okay.
They're not going to say on a skewed right that question don't exist. That's
fine.
later on in your third or fourth semester statistics if you learn to take, if you want to take this stuff. But that's mostly everything that you're doing in this class is based on a normal distribution. Okay. All right. So that's pretty much ending 3.1 or 3.2. Something I think it's 3.1 and 3.2. Because 3.1 is finding the mean, median, and mode, and 3.2, I think, is finding the standard deviation and all that stuff. I think. And 3.3 is z-scores, which I'm going to skip over today and come back to it later. And then 3.4 and 3.5 is quartiles and box plot, which we've already covered. So this right here, 3.3, I think this is 3.3. Go ahead and write those down. If it's not 3.3, just find out where it is and change it. I'm not really worried about it. This is finding the mean and the standard deviation of a frequency table of a chart. Now, I'm going to do two examples today because this is a test question, and I think it's, do not let the formulas intimidate you, because we're going to do them just like we did the standard deviation in columns. I'm going to give you a problem, and then we'll put it in the Excel spreadsheet, and then you'll see how we do it. I got an email this weekend. I got 2 or 3 emails this weekend. I did not respond to it. Why?
They're trying to sell you something.
No. They asked me something that's on the handouts. One of the questions was, is all the homework online? Another question was, are the tests online? And then the last one of the last, I had 3 or 4 asking these same questions. And then one question was, when is the first test? You're talking about 4 or 5 people.
Yeah. So they obviously missed the test on that.
Yeah, it was January 31st. 3 o'clock Sunday, yeah.
If you just share out, you get
100 points, yeah. Now, you really don't have to write the formula for standard deviation. Why? Because it's just square root of variance. You really don't have to write this. You just take the square root of that and get S. I mean, just make a note. You don't have to really write this. But it's these two that I want you to really know, because once you find the variance, then all you got to do is take the square root. We're going to spend most of our time on that today, and then I'll cover some more of the quartiles and the 5-number summary, and then at the end we'll cover z-scores. Well, we'll cover z-scores at the end, because z-scores were really not needed until chapter 6 or 7. So I'll wait until the end to do it so you can let all this stuff sink in. Because probably of the 80% that is from chapter 3, a good portion of it's going to be mean, standard deviation, mean, standard deviation. Okay? So there'll be some z-scores on there, but z-scores are pretty simple to calculate. Now, it's very important that you, like I told you with the mean and standard deviation of a regular set of data, like test scores, I told you to read the formula. All right? Read the formula. Okay? First of all, the summation of f times x. Okay, we know what frequency is. F is frequency. Well, what the heck is x? X is the midpoint. Write that down. X is the midpoint. So now I'm going to take my handy dandy whiteboard and condense it, and I'm going to pull in. Now I'm going to go to the next screen, and I'm going to pull in my handy dandy formula. Put that over here, make it condensed a little bit, and pull in a problem. Let's start off with something simple. Okay, write that down. This is a frequency distribution. What's the difference between this and what we did last week? Last week was like test scores. 78, 42, 37, whatever. There was 7 or 8, 10 test scores, and you found the mean and standard deviation. That's not what we're dealing with now. Now we're dealing with a frequency distribution. And you've got to find the mean and standard deviation. Now, are you talking about a sample or a population? Well, this looks more like a population. Why? The BA numbers, exactly. Look at those numbers. You're talking about dang old states. Talking about big numbers. But you can't make that generalization unless the question says it's population. But we're going to find the average of the frequency distribution. While y'all are doing that, I'm going to pull up my Excel spreadsheet. I'm not on the clock right now.
Why is the last one? Why is the 700 to 800 instead of 700 to 870?
Typo, or it just finishes out the actual class width is what? 100. I don't know unless they started with 200. Maybe they just wanted to close it out with 800. It should be no. I guess that's the max you can score on SAT math. That's why they can't put 801 because it doesn't exist. They can't put 799 because if they put 799, they have to put an 800 down here, and 800 is not really a class, so that's why. The class width is still 100. So, take my handy dandy Excel spreadsheet. I'll pull it up. Yeah. 99. 99. 500. 599. 600. 699. 700. 36, 305, 93, 968, 459, 10, 467, 855. 286, 518, 104, 334. Okay, so there is the problems or the classes. I'm going to put them in the center because I can't stand for things to go to the right or the left. Really don't like that one, but I'm putting them away. This is number. I'm just going to put number. What number of students taking the SAT are scored, and this is your lower class limit, and this is your what? Upper class limit. You know your pet peeves? Well, when stuff's in the back of my truck, I can't stand for it to be sitting level. And I can't stand for like lower class limit and upper class limit be on the left hand or right hand side of the box. I can't stand that. So I really am having anxiety attacks about this being on the right-hand side, but I'll be all right because I need it away from this over here. I should just do this is what I should do. I should just that. Huh?
You're suffering.
Yeah, I am right now. I need a pill. But anyway, there, that's better. All right. Now, if you pull in your handy dandy, I don't know if I could do this or not, but I'll try it. Yep, there it is. Pull in our handy dandy formulas. No, I thought I was going to try to do it. We need F. Well, I'll take that number out right there, and there's F. It's supposed to be lowercase. That means I got my caps turned on. I suck. There we go. So there's F. We got F. Oh, we need summation of F. What is that called? It's called N, Hubert. Yep. Summation of F is really called M. N, as in November. So there's F. Summation of F. Or N. So that's that part right there. But what's X? Well, X is the midpoint. Well, if X is the midpoint, then I've got to find the midpoint of each class, right? So that's why I put them in separate places in the Excel spreadsheet so I can find the midpoint. So what's the midpoint? You take the lower class limit plus the what? Upper class limit and divide it by what? And then you dang old copy that down, dang old Excel. There it is. All right, now we read our formula. What does the formula say to get our mean? The summation of F times what? X. So that means I got to multiply F times what? Okay, so I got to give a column over here, and I'm going to call it F times what? X. I'm going to take F, and I'm going to multiply it by that, and copy that down. And you need to do the first number, the middle number, and the last number, so you make sure you got your numbers right. Do this first number, do 36,305 times that, do 459 times that, and do 104 times that. You don't have to do every single one of them in your notes. Just do the first, middle, and last to make sure you understand where you got it.
Mr. McClure.
These are not centered.
Mr. McClure, what did we do to get X?
I'm sorry. Hold on. You just scared the crap out of me, but that's all right. Hold on. I don't know why Skype does that. It scares me. It's like the computer's talking to me. All right. What was your question?
I missed how we got 249.5 for X.
Okay, that's the midpoint. I'll put it right here. Okay, the midpoint, and I'll put it down here. Midpoint is equal to the lower class limit, that's the number on the left, the 200, plus the upper class limit, which is the 299, and you divide that by 2. Do that for each of your upper class limit, lower class limits. You find in the middle of these two numbers.
Okay.
And the reason you're finding the middle of these two numbers is you got two numbers. You can't calculate two numbers in the formula. So you have to find one number that represents both numbers, and that would be the middle. Now, what are you supposed to do with F times X? Add it all up. So your numerator is going to be a BA numerator. All right, now I want each of you to take your numerator and your denominator and divide it out and see what you get for x bar.
Facebook message.
No sniffing in the class. Truck down the tick is making me very mad right now. Long time ago, they told us if you sign up for direct deposit, you'll get your check a day early. Well, that day has been decreased down to like 6 hours. Today's the day before the last day of class, and the last day of the month, right? I'm supposed to get the check, but I think they've taken that 24 hours, and I think they've chopped it down to like 6. Them damn Russians is what it is. Russians' fault. No, it's not. It's the moderator's fault. No, it's not. It's the women's fault. Did y'all get 519? Yes, no, maybe?
Maybe.
So what is the average score of all those people that took the math portion? 520. Which sucks. So this must be South Carolina or Mississippi. Okay? Okay, now I want you to look at the variance. What do we have that we know the definition for in that formula? N, yes, we got N. We got F and X. So all we got to do is put it together. There's one thing that we don't have. We don't have a column for one thing. And what is that? No, we got N right here. F, no, not F, but X what? So we got to make a column for X squared. We'll go right here and make a column for X squared. All right, I want everybody to do that one. Take X and square it. Let's do the whole column. This is all what? 7 numbers? 6 numbers?
I didn't get 519.
I'll do the first one for you. 249.5 raised to the what? Second power. There, I did that one. Now you do the rest of them. And like I said, read the formula. Check your numbers with mine. And now I want you to go through and do parts of the formula. I'm going to do the parts of the formula down here. I'm going to do it step by step for you. S squared is equal to, the first thing we got to do is we got to find what? N? We found N. N is this number right here. And then we're going to multiply N times F times X squared summation. So that means I got to take F, and then I got to do what? Sum it up, Hubert. That's right, class. No. Read. Hold on. As soon as I get hold of my... This is one irritated. There. Okay, what does it say? Summation of F times what? Have we multiplied F times X squared? Okay. And we need to multiply F times X squared. So I'm going to go over here, and I'm going to do it separately over here. I'm going to go F times X squared. So that means I got to take F, which is this number, and multiply it by what? This number. Now I'm going to let you look at that for a few minutes so you can see what's going on. And you need to make a note in your notes what you're actually doing. F times X squared. Read the formula. The formula says, first thing you do is find N. Then the second thing you do is find F times X squared and then add it up. And if you're not following along with me, I'm right here. Oops. I'm right there. We've already found N. The N is right here. Now we've got to find the summation of F times X squared. And there's F times X squared. And now I got to copy that down and then add them up. Now, it should be a big number. Why should it be a big number? Because your second number, this over here, is going to be even bigger. So it's going to have to be a big number. All right, that's big enough. Hold on a second. That's big enough. Just take it to 2. There. Okay, so that number right there goes right here. Okay, so now we've got N. Let me get this back over here. There. I'm going to move this over. Okay, so we got N is equal to that. The summation of F times X squared is equal to that. And I'm going to put minus. The reason I'm putting a minus symbol is I've I'm writing minus. If I put a minus symbol there, it's going to say syntax error, and I've always done it like this. So just read the word. Okay, and then what is this over here? Let me move this. What does that say? The summation of f times x, quantity squared. Well, don't we have the summation of f times x? It's right there. So I'm going to put equals this number raised to the what? Second power. Oops, not 0.2. I'm putting everything in the formula right here for you so you can see what's going on. Over n, or what's n? N is this number right here, times what? Blank minus 1. That's what you should be plugging into your formula. Right there. I'm going to rush it to go. Look at Hillary, she'll scare them all. She'll give them a reset button. And some plutonium, yeah. Oh yeah, she's already given them plutonium. Forgot about that. Oh yeah, the news didn't report that. All right, start calculating. Well, I'm going to go ahead and start it off for you. This is going to be a BA number. Well, it's going to have to be, because that number right here is a BA number, and you're going to square it. So this number is going to have to be bigger because you can't take the square root of what? A negative number, Hubert. That's right. Over this number times this number. All right, check your numbers and see what you come up with. N times what? N minus 1. So take n, there's n, and then n minus 1. All right, keep doing the math. Yeah, that's 2.4 times 10 to the 12th power. 6.5 times 10 to the 17th power. 6.8 times 10 to the 17th power. And this number has to be bigger or equal to what? That number. Because you can't take the square root of a negative. So if this number is not bigger or equal to this number, you've done something what? Wrong. Just because you do the work does not mean that you're going to get it right. Okay? There is a possibility that you might get it wrong. It's kind of like when you're in a competition, there's a chance you might what? Lose. You win, you lose. Keep your job, you get fired. Make an A, make an F. Everybody got that? You fail, you don't go to the second grade. UB does not believe in social promotion. I'm sorry, but you participated. I could put that on your transcript. And you have a diploma. Them job. All right, who's got a question? Come on, speak up. I usually don't go through this and not have a question.
It's not gonna be a test.
Yeah, it is. You're going to have 10 on yours. I like your shirt and hat.
Mr. McClure,
Hubert, what?
could we do another one with,
I've got
Smaller
another one
numbers?
planned. Huh?
could we do it one with smaller, more,
Yeah, I tried to find one in the book, but that was impossible. All of them were big. I'll make one up, okay?
Thanks.
All right? And I'm going to do the math over here. Equals this minus this over this. And then right here equals this divided by this. And there is your variance, which really is worthless. But if you take the square root of that, that's your standard deviation. So I'm going to color this. I'm going to color this a yellow. And we will color this yellow. So now all you do to find your standard deviation is what? Take the square root of the variance, Hubert. That's right, class. Good. S is equal to this number raised to the what? 0.5 power. Now what I want everybody to do is draw a normal curve and do the empirical rule, not the empirical rule, but put the mean in the middle and the standard deviations to the right and the standard deviations to the left, and tell me where 95% of the populations fall between. In other words, what's the normal score? And I'll color this magenta. Well, I don't have a magenta. Let me go find a magenta. Well, it's more of a mauve. There's magenta. And then we'll color this magenta. There we go. So that means you're going to have a, I don't know how that happened. I'm just going to draw a line, make it black. And in the middle, that line is the mean. I'm not going to use decimals, I'll do digits. Our mean is what? 520. Okay? I'm going to use 520 because I'm not going to do decimals. You will have to do decimals. There's 520. And our standard deviation is 120. Okay? So that'd be 6 what? 40. And what's 120 plus 640? 760. And what's 520 minus 120? And 400 minus 120. About 280. So, normal falls between what? 280 and what? 760. So anything outside, okay, add one more. 760 plus 120 is what? 8 what? 880. And anything below 280, 120 would be 60. I have no idea. What is it? 160? 160. So if you scored below 160, you're an outlier. I ain't gonna say what you really are, but you're an outlier. The S word comes into play. If you're above 880, well, that's impossible because what's the highest score you can make? So if you're 800, you're unusual. Just like if you were between 160 and 280, you would be what? Unusual. How many, and you throw in your right here, right here, right here, right here. How many scored below a 64? Or 640, 80%? How do you get that? Well, or whatever, 34%, 34%, and 16%, or whatever it comes out to be. I think it comes out to 84%. How many scored between 400 and 640? 68%, 34 and 34. How many scored below 520? Percentage. Look at it, that's half full. Remember your gas tank? This is 0, this is quarter full, this is, or somewhere in here, it's quarter full. Sorry. This is half full, somewhere in here is 3/4 full, and this is about what? You read like that. Okay. Now see, that's how you find the mean and standard deviation of frequency distribution. So now, after all that, we know that the mean score is what? 520, and the standard deviation is 120, which means that pretty much the numbers are, the variance is not very high, considering that the lowest is whatever the lowest came out to be. What is it? 200, 299, and the highest is 700 to 800. Those 3-digit numbers of 120 is fairly small compared to those numbers. So now, what if it was 500? Well, if you had a standard deviation of 500, and I can tell you right now something was wrong with the test, because it'd be all over the place. All right. If you had a mean score of 520 and a standard deviation of 500, something's wrong. Or if you had a standard deviation of 2, well, that'd be wrong too. That'd be messed up. It just wouldn't be right. And that's what you have to learn when you're doing the mean and standard deviation. You have to put the standard deviation in context with the numbers. If you get something way out of wampus, you ought to be able to tell it. And 120 is not that bad. But a 300 or a 2 would be not good. It would say that the test, something's wrong with the test.
So if you had a real high standard deviation, would that mean you had a lot of very high scores and low scores? Or if you had a bunch of low scores?
It means there was a lot of variation. In other words, there's a lot that's going all over the place. Just remember the ping pong ball in the room full of mouse traps. What happens to the ping pong ball? It goes all over the place. Or if you can't fathom that, remember SpongeBob and Patrick Star, when they did hit each other going around and around and around, they go all over the room. Remember that, okay? One of them did a whirlpool, and the other one did a reverse whirlpool, or whatever you call that thing. They were dancing, and they forget it. All right, let's do a nerd. I'll make one up this time, okay? I'll make small numbers because Mr. Ellis, he can't write these big numbers with his crayon. Okay? So, what? I know. So let me hit erase. What? What did he say? That's not going to be on the test either. All right, I'm going to put 10 to 19, 20 to 29, 30 to 39, 40, 49, 50, 59. I messed up one of my numbers there. That'd be 40. And 60 to 69. And then I'm going to put, these are ages of students. And I'm going to make them up because I don't want to make anybody mad at me, so I'm just going to make some up. And we've got 5 students that are in here, that number, and then we've got 10 students here, and 3 students here, and 1 student here, 0 students here, and 1 student here. Okay, now I want you to find the mean and standard deviation of this class. The first thing you're going to have to do is, find the mean. And that is the summation of f times x over the summation of f. And this is f right here. Okay, I want to go see a movie. I want to go see The Mummy. I love Egypt stuff, so I want to go see The Mummy. Yeah, that was stupid. Yeah, I didn't even make it through half of it. I turned it off. Didn't like it. I like The Mummy, and I like the second Mummy, Mummy Returns. The third one was stupid. Didn't make it halfway through it. I love when I took art appreciation. I took like 3 classes of it, and at Clemson, and I really was fascinated by the Egyptians. So I watch Egyptian documentaries or History Channel. So I love the movies when they do one on Egyptian mummies. This was a twist. This one is kind of like ISIS. One of the, I don't know who it could be, because the only woman that really was a queen was Hatshepsut. And she kind of like slapped Akhenaten around. So, and then there was Nefertiti. Can't say it. Nefertiti or Nefertiti. I think it was Nefertiti.
Yeah.
Nefertiti was in the Mummy. They changed her name. Nefertiti was married to Akhenaten. And Akhenaten, he didn't live very long because he was all messed up. He was a man, but he had a woman's body.
Is it in the movie?
Not this, I'm just talking about real history.
Oh, really?
Yeah. He's messed up.
He's confused.
He's famous on don't know what he says. You ever watch an Egyptian movie? They're all beautiful and they're all, they wasn't pretty at all. They had some messed up teeth, some overbites.
Yeah.
Bad. Yeah. They was not pretty.
That insect will get you every time.
Have you seen the DNA test of King Tut
Yeah.
and how inbred he was?
Yep.
That was crazy.
That's why they didn't live very long.
Except for that one Ramsey that lived to like 90. Those
Ramesses
crazy
second,
things.
Ramesses first. Yeah. That was the one, the actual slaves, Israel was in Ramesses, I think. Ramesses and Ramesses second is the one, his son. That was, yeah. I found it interesting that they actually found a link between Moses and the pharaohs, because the pharaohs were also called like Tutmosis. I can't say it, but that has something to do with the reason Moses was named Moses. It's because of the Egyptians naming their pharaohs like Tutmosis or something like that. Because Moses was not originally named Moses; he was named Moshe.
Yeah, he worked his way up real high in the ranks, you know.
Yep. That's interesting. I think the whole Egyptian Old Kingdom and New Kingdom, I just think is amazing. It does make you wonder though if aliens didn't have something to do with them, because of the mathematics that the Egyptians was unbelievable. I mean, it was just unbelievable to be able to put those stones on the pyramids. You can't even put a toothpick between them.
And you know the ones broke down that he found.
Yeah. And they're lined up with the same stars as Orion's belt.
Yeah.
How did they do that? Heck, I have a problem just building a square. You know,
Yeah.
How did they do that? Just, I know. And one of the pyramids, every once a year, the North Star and the sun shines through a little peephole and shines onto a seal, and I'm like, how did they do that? It was the Russians.
Maybe one of those nuts is what they do.
Makes you think.
But we just assume we're on top of everything, something.
I'm not gonna say anything. Russians. I know the Russians gonna take care of that.
Public good.
All right, what's X? X is called the what? Midpoint. If you don't want to call it midpoint, call it the middle of your classes. So that's equal to, parentheses, 10 plus 19 divided by 2. I'm impressed. Copy that down. Check your numbers. Put them in the center so your teacher don't have an anxiety attack. I need drugs. All right, so here is what you have to calculate first. So I'm going to put a mark, highlight that in yellow, and the grid really bothers me, so there we go. All right, so that's what you have to do first. You have to find the midpoint. Then what do you have to do? You have to sum, you have to find n, and the summation of x, or f, is equal to n. So that's going to be equal to all those added up. Okay, so now you've got everything you need to find your mean. Okay? Now, well, not everything. I mean, you've got everything to calculate. Now, I've got to find f times x, because for my calculation of my mean, I have to multiply f times x. Oops, wrong place. F times x. That's equal to 5 times 14.5, and then we're going to copy that down. And I'm going to color that green because that's part 2. Okay, now I'm going to go over here and I'm going to say mean is equal to, and then all you have to do, well, you got to sum that up, sorry. Is equal to 530 divided by what? 20. And that's your mean. So what's the average age of your students in this class? 27. Why? Why is it 27? Why isn't it 54? Because this is skewed right, which means most of your data is on which side of center? Left side. If you take your normal distribution, right here, let's see, I'm sorry, all your stuff is right here, and the center is right here. So all your data is on the left of center, so it's skewed right. Okay? What?
Yeah.
Well, I'm sorry, I couldn't find one in the...
They start us off in the trees.
I know, I'm sorry.
Is it gonna be higher numbers on the side?
No, it's probably going to be like this, something like this, maybe a little bit bigger.
Quadrillions, something like that.
Except for these two, they're going to have quadrillions. All right, so now I want you to find the standard deviation. And you can have a place for variance if you want to, but I don't really care about the variance. The book, the test, and the homework might, but I'll give y'all a few minutes to work on it. Yeah, I sent out an email today talking about the losers. I'm sorry, the students that haven't registered and the students that haven't done their homework. Out of 22 students, there's 22 on the roll, 19 have registered, which is good. I'm happy with that. The part I'm not happy with is only 5 or 6 of y'all are at 3.1 homework. Especially when the first 2 chapters was just reading and a few questions.
I got so sick of this definition.
I know. You should be on 3.1. Okay? Now for the online class, I've already set up the test because I've got about 6 or 7 students that want to move ahead and they've asked me, so I went ahead and put it up. But I haven't done that with y'all yet because y'all are a conventional class and we're probably talking about a test after Thursday. But that means the next week I'll go through everything and I'll go through a test and I'll cover the dates and all that. And then whenever I set up the dates for y'all, I'll set up the dates for the online. I just opened the test for the online for those 6 or 7 students that already finished with their homework. And of course, they're probably students that had probability and statistics in high school, which means they just graduated or they had it within the year and they remembered all the stuff. Or they read a lot and go ahead and read through the book and go ahead and independent study type students. So we've got 2 more sections to go over and then we'll be finished. So we'll probably talk about after Thursday, latest Tuesday, we'll probably be talking about a test next Thursday probably. So that doesn't mean you need to start hyperventilating, okay? But some of y'all, out of 19 students, about 13 of y'all need to get on the ball. And then we won't even talk about the 4 or 5 who haven't even registered yet. I know, your grandmother died 5 times and you had 6 flat tires and your dog ate the computer and whatever.
Well, that pre-trial thing, you said it gives how many days?
14 days. I thought it said 21, but that must be another class that I'm thinking of.
My problem is, I just signed in from last semester, and it just took me right in June, and I've tried to look like subscription. It hasn't told me you're going to run out. I mean,
I understand.
Yeah, I've even went through.
You haven't taken 120 before?
No.
Then you're on the free trial period.
So
It's going to get you.
I've got the product thing, I thought, man, this is going to take. I'm
No,
gonna
just
ride this train.
whenever it comes up, you need to use it. Okay?
Okay.
It's going to get you. Eventually it will.
So when they
No, it won't give you an access code if you go online. It'll just take you out of the 14 day and put you into the access code is just a proof of purchase. So once you buy it online, you don't need to type it in. It's going to automatically take you into the full-time school. Okay, so remember our handy-dandy formula sheet. Let's bring in our handy-dandy formula sheet.
And again,
All right, here's our formula sheet. I'm going to make it very small. Okay, there's our formula sheet. We need f times x squared, so we're going to need x squared. So I'll put it right here. X squared. Wait a minute, I'll go down here, and we'll do part 3 down here. X squared. That's equal to this number. Oops. Raised to the what? Second power. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes.
On variance, where it says f times x squared, is that the sum of that?
Yes. See the summation right in front of the parentheses?
Oh,
Yeah. Okay, we got f times, we got x squared, but now we got to do what? F times x squared. So I'm going to go right here and I'm going to put f times x squared. So equals f, which is here, times x squared. And y'all check my numbers with your numbers.
explain this thing first.
Yeah, I learned that somewhere. Somebody told me that in the past. So now I've got n. There's n. I've got f times x squared. I got to sum it up. F times x squared. Sum it up. Go away. Go away. Okay, I've got that one. Minus. I got that one. Oh, I'm ready to go now. So I'm going to go right here and we'll call this part 3. We'll just color this that magenta. And that's part 3. And now I'm going to go here and I'm going to say variance is equal to, and what's the first thing that comes in the variance? N. Well, that's equal to, right there. And then what? The summation of f times x squared. That's that right there, right? Minus the summation of f times x, quantity squared. So that would be equal to this raised to the what? Oops. Okay, let me try that again. I messed it up. Equals to this. There. Raised to the second power. All over n times what? N minus 1, Hubert. That's right, class. Thanks for the interaction. That sucked. All right, everybody see where I got everything? So this is what it should look like when you plug it into the formula. What'd you say? That's N. See the N right there?
Did it just copy the numbers? And your F times X squared.
Yeah, I just brought it over from here. Where, right
That's the
here?
results.
Right here. That's F times X. This is
You're
F
talking about
times
in
X.
your magenta column.
Yeah, that's the summation of all that.
But your,
Yeah, I brought it in from up here.
but it doesn't look right. Okay, it does. Never mind. Not, well,
I took this number right here, multiplied it by
just
that
because you
number.
had one. That's what it is.
What?
I was thinking it only copied it because your multiplier was only one.
Hold on. I might have took the wrong one. Okay.
You
F.
see what I'm saying?
Yeah. F times. Is that what I had?
Yeah.
Yep. 0 times
Yeah,
2970 is 0.
Yeah, and it's the one is what threw me off. Cause like your last column is 1.
1 times 4160 is.
I was thinking maybe they would copied it, but that was just 1.
Are you on drugs?
Yeah.
That comes from My Cousin Benny. Great movie. Love My Cousin Benny. Are you on drugs? No, Judge, I don't take drugs. I don't like your attitude. Oh, there's a big surprise. I actually said that to a class one time, and I had 2 or 3 people say they'd never seen My Cousin Benny, and I was like, oh my gosh, that's like saying you've never seen Caddyshack, or never seen Animal House, or never seen... My Cousin Benny is a classic.
Keep going. Name a few more. Sit back and then check out that. So.
I'm not going to say anymore. It's real sad. And it's your parents' fault, really. It's not your fault. It's your parents' fault. Just like when I tell students, don't get the cart before the horse, and they say, what's that mean? It's their parents' fault.
It's something about when you say it's not your fault. That's like soothing words to me. It just feels so good.
Everything's your fault.
I was thinking I had to be concerned.
Exactly.
I think you said that.
All right, multiply that number times that number. That's that number. Minus 530 raised to the second power. And what will you know? What tells you if you're right or wrong at this point? This number has to be larger than what? And if it's not, then something's wrong. Let's see if I can do 29 times 19 in my head. Go ahead, I'll just do it later. Go ahead. You interrupted me, might as well go ahead now. What?
The 335,000.
This one, multiply these two.
Oh, okay.
Thank you. I'm glad I'll be in charge for a while. That comes from Full Metal Jacket. I'll be in charge for a while. Sir, yes, sir.
Yeah, that's where that came from.
What?
That.
Mm-hmm. Lee Herman, I love him.
That's a good story.
Yeah, it is. He is. Well, that's what basic training is like.
Well, not quite that.
We had one drill instructor get demoted from a sergeant to a corporal, and because he threw one recruit down 3 flights of stairs.
He got demoted and not like prison.
You gotta remember, that's property. You're the federal government's property. It's like a trash can. Until the snowflakes take over, and then when the snowflakes take over, then we'll have safe spaces on all barracks. And divide by 380. And our variance is equal to 400 divided by 380. And that's our variance. And then it's real easy to find the standard deviation. Standard deviation is equal to that number raised to the 1/2 power. That number raised to the 0.5 power. I got 12. So draw a normal distribution. The mean is, I done forgot it, 27. Yeah. The mean is 27, the standard deviation is 12. So since I've got somewhere to draw on this one, the mean is 27, the standard deviation is 12, so that means you're going to have what, 39 here? 39 plus 12 is what? 51? Y'all check me. I have no idea if that's right. 27 minus 15, or minus 12 is what? 15? 15 minus 12 is what? 3? Y'all check my math. Take the square root of 143. Take 143.1579 and take the square root of it, or raise it to the 0.5 power. Now, look at the standard deviation. The standard deviation is 12. The mean is 27. That's normal. I mean, you can have, what if you had a mean of 27 and a standard deviation of 102? Then you've done something wrong. Okay? What if you had a standard deviation of 1? That wouldn't be right, because that would be saying that normality would be 31 to 27 in the classroom. And y'all know somebody in here is 18 years old or 19. Okay? You've got to, just like everything else in real life, you've got to put it in what? You've got to put it in context. If you get a normal distribution, I mean, if you get a standard deviation of 9, 10, 11, maybe even 12, 13, you're doing okay. But anything below a 5 or anything above a 20 or a 15, you need to start questioning, because if you had a standard deviation of 20, then that would be 27 in the middle, and 20 would be what? 47 and what? 57 or 67, right? And 7 and negative 13. All right, now there's two things here that tells you that something is wrong. What? The negative 13, you can't be negative 13 years old. You're dead, okay? All right? You can't be negative, or you haven't been born yet. All right? That's impossible. What about okay, and that compounds into the next problem. Normal is negative 3 years old to 67 years old in a classroom. Maybe if you're teaching at Geritol University, because 67 is basically an outlier in any classroom, unless you're talking about a classroom for senior citizens. Okay? So that context. Context, yes, you could have a 5-year-old. You could. I've had a 12-year-old in some of my college classes. I've got a 15-year-old right now taking one of my online classes. And I had a 16-year-old taking my calculus class 2 or 3 semesters ago. So you can have out of the norm in your, in your data. Well, let's say you had the opposite. Let's say you had a standard deviation of 1. I don't know what to get this kind of thing up for. I wouldn't use it even if I wanted to. Okay, so standard deviation of 1. 27, 28, 29, 26, 25. Now what's wrong with this? 95% of the population falls between 25 and 29 years old in the classroom. Again, that would be a classroom maybe for bartenders. Because you're not going to have a 60-year-old bartender and you're not going to have a 17-year-old bartender. Because what? You got to be over what? 18 or 21?
18.
That was 21.
You would think.
Well, no, in South Carolina, you know, you can be 18 and fight for your country, but you can't take a drink. I'm sorry, there's some things that just don't make any sense. And that would be right in South Carolina. You could serve a drink at 18, but you can't drink it. Yeah, that would fit in with South Carolina's logic. Okay, you see what we're doing? Okay? So, look at the context. So right now, you should be able to find the mean and the standard deviation of a set of data like test grades. And you should find the mean and the standard deviation of a frequency distribution. I think we're talking 3.1, 3.2, and 3.3. I'm not sure. But 3.3, we also start getting into z-scores. 3.4 and 3.5, I think, is quartiles and box plots, which I'll cover that next. So we're probably talking about finishing probably Thursday. Okay, I don't even know what time it is right now. What time is class over? 2:30, 2:15, 2:10. So you're working on failing this class, okay? All right. Right now, and I'm talking to most of the losers, I'm sorry, the students that are on like 2.1 homework, okay? Y'all need to get your butt in what? Year?
Yeah.
You need to be this 3.1, 3.2, and 3.3. That's what everybody should be working on, those three sections right now. Should you be finished with 3.3? No, because I haven't covered all of 3.3 yet. So right now, everybody should be working on those three, but not going over those three, okay? All right, let me do the, what you call it. Okay, Mr. Hoyt and Ms. Grant, y'all have any questions?
It was 15. I know it's when you're talking. I counted right after I went to the top.
I'm okay, Professor.
Do y'all have any questions?
I'm all right.
Okay, was that last problem better for you?
Yeah, it was a little easier to understand with the smaller numbers too.
Okay. All right. Well, I'm going to shut it off. I'm going to shut the recording off.